Hello, it's Mrs. Green, and this lesson is on surface area of prisms. We're going to do a couple of different shapes and calculate their surface area. Today it's prisms. And so, of course, you're going to put your prior knowledge, something about, I know you know something about area, so you could predict what surface area might be, and then I know you know what prisms are. So key information, I want to talk about what a net is, and a net is a two-dimensional pattern that forms a 3D solid when it is folded. So I have a picture here of a triangular prism net, and if you can probably visualize that if you cut this pattern out, and folded it, you would have 3 rectangles and then 2 triangles on the ends, and it would fold up into a nice triangular prism. And when we flatten it out, though, it's a lot easier to calculate surface area using a net. So I'm going to focus on using nets to calculate surface area. There are other shortcut methods that I will touch upon as an option if you'd like to memorize formulas. I don't advise that in middle school because usually we spend so much time memorizing the formula we can't remember what we're doing and the concept gets lost. So I would rather use nets. But I'll put it out there in case you're really good at memorizing formulas and you prefer to do that. That's fine. It's good to have more than one method. So the second definition here is surface area, and that's what our topic is. If we go back to the topic, it is surface area. And surface area are all of the areas of the faces. So if we folded this triangular prism up, and we added, it's basically you're covering the object. It's like you're wrapping it with wrapping paper. So kind of we talked about regular area being if you cover this circle with fabric. So the quiz had a problem with where you were covering or cutting out pattern pieces and covering them with fabric, and how much fabric would you need? That's area. So some people think of it as the inside. I prefer to think of it as how much fabric or material would it take to cover the shape. So now we're talking about a 3D object, and it's the same concept. You're covering, so that means area. But it's more than one face. You don't just have one two-dimensional face, you have several faces depending on your shape. So in the case of this triangular prism, you are going to have 1, 2, 3, 4, 5 shapes, and you can calculate the area of each of those and add them together to get the total surface area. You would ignore these little flaps. Those are just parts that you need to construct that you would tape or glue together to make the three-dimensional figure. It's not part of the area because those would be tucked in. So in this case you'd have 5 different shapes, and these are rectangles and triangles. We know how to calculate area of both of those shapes, so it's not anything new. The trick is that you have multiple things to keep track of, so you're going to want to be very organized with your work, and then you have to add them all up in the end. The last piece of key information is optional. As I said, I'm going to give you the formula. You don't have to use the formula. I'm never going to require that you use the formula. And I also probably won't give you the formula because, again, my philosophy is that you need to learn how to figure out how to break this figure down into shapes you do know, and that's much more conceptually makes more sense than trying to memorize a formula that you'll forget or doesn't really mean anything. But if you do want it, here it is. I don't want to keep information from you. So the formula goes like this: surface area, which is SA, is a surface area of a prism, which is the topic we're working on, versus a cylinder or a cone or a pyramid. So surface area of a prism equals 2 times base area, this capital B stands for base area, plus perimeter times height. So then down here I've defined the B, that's equal to area of the base. So in this case we have a triangle as our base, so you have to figure out what your base is, and then you would have to calculate the area. So area in this case would be a triangle. The base shape is going to be different depending on the way that you calculate that shape's area. So in the case of a triangle, you have to go back to your area of a triangle formula, 1/2 base times height. If it had a square base, so let's say it was a square. Then you'd have to go back to your base times height. Those are pretty much the only ones we know. Okay, then the second letter here that has to be defined is the perimeter. And again, that's perimeter of the base, so you would have to calculate the outside if you walk around that triangle. And we don't have a formula for that, we're just adding up the sides. And then the height, in this case, is going to be how tall. Wait, is it going to be that height, or let me think for a minute. Yeah, I'm labeling it wrong. It's the line that goes from one base to the other, so that's how we know. The distance from one base to another is your height in a prism. That's confusing. I was a little confused for a minute, but now let's write that. Distance from base to base. So the bases are determining a lot of your dimensions here. Okay, let's do an example. Oh, one more thing I wanted to show. So this is one way to draw a net, which means, and the way you would draw it if you were drawing it from scratch is to take your two bases. So let's do a rectangular prism. So I would do my base, and then down here I would also do my base. And then you would draw in the other faces. So this is got 4 sides, so there's 1, 2, and then 2 more coming off of here. So that's that would be a rectangular prism net. Now let's go back and do a different kind of triangular prism net. Erase all that. If you draw your base in the middle, so remember it's a triangle, then do your faces off of that, which are all rectangles. They look kind of like flaps. And then from off of one of those, you have to draw your other triangle. So I don't know if you can imagine that, but those would all be folded up. And these would be the sides, side, 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 bottom, top. So 2 different ways to draw the nets. Okay, so example 1 is a rectangular prism with some dimensions labeled, and I'm going to add some dimensions because you have to realize that this rectangular prism has a lot of the same dimensions. So I'm hoping you can imagine, so that the two, let's say the front, let's call this the front, and this is the back, top and the bottom, and then side 1 and side 2. So the front and the back have to have the same dimensions. It's a rectangular prism. So 15 is also going to be here, and 30. And then the sides are the same dimensions, 10 and 10. So we really only have 3 numbers that we're talking about, 10, 15, and 30. But each one of these rectangles is a different size. They're not all different sizes because, again, the top and the bottom, once you do one of those, you'll have the other one. I kind of don't like the flaps on here. I'm gonna find a better picture. Okay, I like this one better. Doesn't have all those flaps. Those were annoying me, getting in my way. So we've got the dimensions labeled. This is, again, a rectangular prism. If you fold this up, it would turn into a little box. And we can calculate the surface area. So the example 1 is going to be calculate surface area. And you can use the formula, or I think a better way is to count all of the faces. So we've got 1, 2, 3, 4, 5, 6 faces, and do a calculation for each one. So face number 1, and I want you to keep your work organized. I know this is going to seem like a lot of writing, but you need to invest in yourself and keep this organized. So you want to label face number 1. That's going to be 4 by 8. It's a rectangle. You all know how to do rectangles. 32. Done. 32 centimeters squared. Face number 2. 8 by 6. 48 centimeters squared. If you don't label these and keep track, I guarantee you're going to start making mistakes. 8 times 4. I might make a mistake here, even though I'm trying to be very organized, because you can see a lot of the numbers are repeated. It starts to get confusing. 8 by 6 again. And you can start to see a pattern. I had two 32s and two 48s. You could have shortcutted that. I don't suggest that you do. But you can notice that there is a pattern because you've got a lot of the same dimensions repeated over and over again. So you're going to come up with some of the same numbers, and that should make sense. You should have 2 of each. And number 6 is also 4 by 6. And you're not done. You have each rectangle has been calculated, but now you've got to add them all up, total them up. So 10, 28, 7, 14, 16, 18, 20, 208 centimeters squared. If you want to use the formula, I'm going to do an example with the formula. Example 2 will be with the formula. You can skip it if you don't want to learn how to use the formula. It's optional. So the formula for surface area is 2 times the base area plus the perimeter of the base times the height. So down here I've got base area, which is going to be, the base is this part. So 4 by 6. I know that's the base because these are the perpendicular, or the parallel congruent shapes. So 4 times 6, that's 24. So surface area equals 2 times 24 plus perimeter of the base would be this, which would be 4, 10, and 10, which would be 20. So that's 20. And then height is going to be the distance between your two bases, which is 8. And so that's times 8. The surface area equals 48 plus 160. Surface area equals 8, 14, 248. Nope, I'm adding wrong. Mrs. Green, why don't you just line them up like you're supposed to? 160 plus 48. 80, yay, 208. So I was like, I have to get the same number. And that's centimeters squared. So we get the same number either way. You might think this is faster. It's fine. As I said, it's an option. Okay, the 2 practice problems are out of the textbook. If you can't read them, you can go there, page 575 out of the blue textbook. The number 2 is a little blurry. It's 6 meters, 8 meters. This is a 6. This is an 8. 14 and 10. So you need to find draw a net, practice drawing nets of both of these, and then find the surface area of each shape. And then do your wrap-up summary.